I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take two questions based on geometric probability. Well, in geometric probability, we are looking at probability involving geometric measures like length and area. So we'll have questions based on what is the probability of being on a segment, a portion on this segment, or in a particular area when we have examples involving area as shown here. In this video, we'll take up two questions. One of them is finding the probability of being on the overlapping segment, and the other will be a real life situation based on waiting time at the railway station. So let's begin with the very first question, which is point X is chosen at random on AB. So that's the segment AB. Find the probability that it is on PQ, right? That is one. And second is find the probability that it is on P2B. So that's the first question for you. So the basic concept here is that the probability, let's do question 1A first, right? So probability of X being on PQ will be what? Well, length of PQ, which is 5 units, right? So length of PQ, as you can see here, is 5 units. So we'll take up that length of 5 units over the total length A to B, right? So I could have written first as PQ over AB, right? So that's measurement of length, right? So that is the geometric probability. So PQ is given to us as 5 and AB is 3 plus 5 plus 6, right? So it's 5 over 14, right? That becomes the probability for case A, right? Similarly, now you can do question number 1B, which is point X is chosen at random on AB. Find the probability that it is on PB, right? P to B. So in that case, the probability we want X to be on P to B, right, will be probability ratio of these lengths basically, right? So P to B is 5 plus 6 and A to B is 3 plus 5 plus 6, correct? So we have 11 over 14 as this probability. Make sense? So that is what geometric probability is. And now let's take up the second question, which is a real life application on geometric probability. Well, in case you want to learn from me, you can always send an email on the address given. The question here is a TTC transit train departs Union Station every 10 minutes. If you arrive at Union Station, what is the probability that you will have to wait for 4 or more minutes, right? How will you do this? So let's also understand that this arrival time could be is length of time, right? So waiting time is length of time, let's assume that. Since it departs every 10 minutes, that means 0 to 10 is the limit, right? You come and you see that the train is there, you just board on, so there's 0 waiting time. But if the train has already left and next will leave after some time, there could be some waiting time. Now we say that waiting time has to be more than 4. So that means somewhere here we are interested in this probability. At least waiting time of 4 minutes means 4, 5, 6, 7, 8 up to 10, right? And therefore, we can say that the probability of waiting will be probability of waiting, let's say W, of greater than equal to 4, right, will be what? So 4 to 10, that distance, so that is 10 minus 4 over the total distance times 10 minus 0, correct? So you can say this is 6 over 10, and you can simplify to the lowest terms, dividing by 2, getting this as 3 over 5. So that becomes the probability for a wait which will last for at least 4 minutes. You get the idea. So that is how we could actually solve probability uh, based questions which are geometrical measurements involved. We'll have another set of videos here which will involve areas, right? So I hope the concept is absolutely clear. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.